Well, good morning, afternoon, everybody. Thank you for joining today's training session on the basics of Tecplot 360. This will be a great way to get started using Tecplot 360 for your own work. My name is Jared McGarry. I'm one of the account managers at Tecplot. I started with Tecplot as part of the technical support team. So I've had quite a bit of experience working with many of our customers. So if you have questions after the webinar, you can reach out to us at support@tecplot.com. But during the webinar, you can also enter questions into the GoToWebinar question field, and we will answer them at the end of the training. Before we begin the training, I just want to say a few words about Tecplot, the company, and Tecplot 360, our flagship software. So Tecplot was founded in 1981 by two Boeing aeronautical engineers who originally started writing CFD codes. They realized that they needed a way to visualize the results, so they hired a developer to do that for them, and that developer is still active at Tecplot to this day. That was almost 40 years ago, and we're still going strong with over 47,000 customers worldwide. Tecplot 360 is known as the most complete desktop post-processing solution. Now that's the ability to render not only beautiful 3D plots like the one shown here, but also quantitative plots with line plotting and 2D plotting where the real engineering decisions are often made. We're dedicated to saving you time in your work, and we do this in several ways by optimizing the way data processing is done in Tecplot 360, reducing the number of mouse clicks for common workflows, and automating Tecplot 360 through macros and Python. We're also dedicated to solving the big problems in CFD, one of which is post-processing large heterogeneous data sets. One of the most time-consuming parts of post-processing is loading data off the disk. And this image here represents our subzone load on demand, or SZL file format, which helps you by loading less data by waiting until you need to use the data to load it, using less RAM because less data is loaded at a time, and performing workflows faster, saving you time in the long run. Tecplot 360 is also a suite of tools, one of which is Tecplot Chorus, which allows you to analyze ensembles of data. For example, if you're doing a design of experiments, this tool will help you to see the big picture and then filter down to the details as a companion to Tecplot 360, getting to the answers you need faster. Tecplot 360 also has a built-in macro language, but more recently, we've included a full-featured Python API, which has opened the doors for more advanced post-processing analysis with Tecplot 360 as well. All right, and with that, let's get ready for the training. So for the agenda today, expected to take about 40 minutes for the training overall, and then I'll do my best to answer questions. I will be helped by my colleague Scott Fowler, who's the product manager for Tecplot 360, to help me field some of the questions that do come up. So to start, I'll do a quick tour of the graphical user interface. I'll then show how to load your data. The dataset we'll be working with is the ONERA M6 Wing, included as an example dataset in the Tecplot 360 install. I'll then show how to explore your data, looking at the zone, styles, and layers, then the derived objects with slices, isosurfaces, and stream traces, or sometimes called streamlines. Then show how to calculate some new quantities, using first the specify equations tool, and then the built-in calculate variable functions. Then I'll show how to extract some data for dimensionality reduction, because sometimes you don't need the full volume data and you want to reduce the amount of data you have on disk. So I'll show how to do extraction with that. And then from there, I'll show some line plotting. One of the real strengths of Tecplot 360 is the full set of X, Y, and 2D plotting features in addition to the 3D. The 3D is great for impressive images, but a lot of engineering decisions are often made with simple line plots, and we do a great job with that as well. And then lastly, I'll show how to export your results using images, animations into multiple different video formats and image exports that you can use for papers, presentations, or sharing with your colleagues. And then after that, we'll answer the questions that have come up. So just a reminder, the dataset we'll be using is the ONERA M6 Wing dataset included in the Tecplot 360 install if you want to try following along on your own. I'll be using the April 2020 beta of Tecplot 360, which you can see from the welcome screen when you first launch Tecplot 360 as well. And if you want to try the beta for yourself or you have already started, we do appreciate the feedback, and contact us at 360beta@tecplot.com. All right, so I'll switch over to Tecplot 360, and let's just do a quick tour right here. At the top left, we've got the menu bar, which includes the file drop-down menu for looking at the loading data sets and opening different layouts. And then I'll be using a lot of the data drop-down menu and the analyze drop-down menu as well. Just below the menu bar, we've got the toolbars, and if I right-click here, we can see the different toolbars we have active. We have the file toolbar, the view toolbar, the data toolbar for manipulating different plot elements, and then the insert toolbar for adding text, images, geometries, and if we want to draw new frames. Just below the toolbars, we have the plot sidebar, which doesn't have anything in it right now because of the lack of a data set that we have currently. That'll change shortly. Below that, we have the frames sidebar. We'll just be working with a couple frames for this training, but this shows a list of the active frames in the current workspace that we're looking at. If we look on the right side, we have the pages sidebar, which we'll just be working with the one page for now, but the page is what the workspace, which is this gray background, is set up on, and the pages contain all different frames for the current workspace that we're looking at. And if we add additional pages, we can click back and forth through them like we would a PowerPoint presentation. Below that, we have the quick macro panel. We won't be using this in this training today, but for reference, you can go to the scripting drop-down menu and see it toggle on and off from there. The quick macros toggle, and you can also record your own macros or Python scripts if you want. And then below that, we have the probe sidebar, which gives us more information at specific data points. Let me just reset this one here. Looking at the center of the screen here, this is the welcome screen that I was describing earlier. And what this is a way to, let me just switch this one over. Okay. Welcome screen is a way to get some quick links for existing data sets that we've been looking at, previous layouts if we want to load any new data, links to documentation in the install. One of these I highly recommend is the quick reference guide, which has keyboard shortcuts that a lot of which I'll be using today for manipulating the plot. It also has some command line options when launching Tecplot 360 and some dynamic text. Below that, we got links to some of our online resources. And then in the bottom right, we got contact information for our technical support team. I highly recommend contacting them if you do have any questions while you're using Tecplot 360. All right, and with that, let's bring in the data set. So I can do that from here by selecting Load Data at the welcome screen, but I can also go to File, Load Data, and select it from the folder that I've already navigated to. In this case, I'm going to select the PLT or Tecplot binary plot file. In the right here, I can select which data loader I want to use to load in my data. You can see we've got quite a few different data loaders depending on the simulation code you're using. I could select the specific data loader that I know will open this data file, or I can select the all supported files, which recognizes the file extension of the file and picks the data loader that's most suitable for that. So in this case, I'll select open and bring in the data set here. So now the plot sidebar lights up with a lot of different options, and then we have all these toolbar options as well. So the first tool of the toolbar that I've got here is the selector tool. So this allows me to select elements on the plot, including the data itself, and then other plot elements that I've drawn on here. If I had any geometries, I can manipulate that. Next, we have the adjuster tool, which we won't be using too much until we get to the XY line plotting, but what this is useful for is a little more fine tuning of your plot. Next is the magnifier tool. I can click and drag to zoom in on a specific region. And if I get zoomed in too far, I can control left click to zoom back out a little bit so we can see the rest of our plot. Next is the translate tool. I can translate my plot back and forth. And then we have a lot of different roller or rotation options. Standard rotation, roller ball, twist, and then these XYZ axis locked rotations. You notice as I'm rotating this, it looks a little clumsy, and that's because our center of rotation is actually at the origin of our data set. If I want to reset the origin of our rotation closer to the data that we're looking at, I can press O on my keyboard, and now we're rotating about that point, and it looks a little less clumsy. Some other keyboard shortcuts that can be useful: click and hold right click to translate, control right click to rotate, and then we can click and hold the middle mouse button to zoom in and out. So if we want to get a little more precise, we can use the tools up here, but the keyboard, the mouse and keyboard shortcuts can work pretty well. All right, let's take a look at the data set that we've brought in. So to do that, we'll go to Data, Dataset Info, and we have the Dataset Information dialog that shows our zones on the left and our variables on the right. So we have two zones. Zones are the regions or paragraphs of data that we've brought in with our data set. So we've got one fluid volume data set and one wing surface zone in our data set, which is what's visible right here. So both unstructured finite element, and we can see the breakdown of the number of points and elements for each zone. Then on the right, we've got our list of variables, or XYZ spatial variables, and then our state and convective variables that we'll be referencing a lot when we add some more plot elements, and especially when we use some of the derived objects. The tab over gives us more information about the data file that we brought in, and then it also gives us a breakdown of all the zones, variables, elements, and points in our data set. All right, next, let's step through the plot sidebar to show some ways we can explore our data a little bit. So at the very top, it shows the plot type, defaulted to 3D Cartesian because we brought in a volume zone. So Tecplot tries to be clever about that. In this case, it's exactly what we want for this plot. I'll show the XY line plot type a little bit later once we do some data extraction. Just below that, we have the snap to orientation view, where we can make quick adjustments to snap to specific views if we want. And then below that, we have the zone layers. So what these are is global on-off switches for the specific zone layer shown here for all zones in this frame. So right now, we're just showing the wing surface, but it toggles on the mesh for the wing surface zone. If we want to get a little more detailed or manipulate things zone by zone, we can double click on the zone we want to manipulate, or we can click zone style dialog to bring up the same dialog. So from here, I could toggle on and off the mesh for just the wing surface. Notice if I choose this toggle, the mesh is still toggled on here because this is the global switch for all of the zones that we'd have available to us. I could also toggle off the zone altogether if I want. I can change the mesh color. And I can also do a lot of this here from right-clicking the zone in the frame itself. So I could change the mesh color to orange if I wanted without having to go back and forth in between the dialog. The next zone layer down is the contour. If I toggle this on, it'll pick the next variable down the list after our spatial variables to pick a variable to make sense to contour along the surface. In this case, it's the density. If we want to change that, we can click this button to open up the contour details dialog. And at the top, we can select which variable we're contouring with. So let's say I want to look at pressure coefficient instead. And these 8 numbers on the right indicate the number of contour groups we can have at a time for all of the zones and derived objects that we're creating in our plot. We can see the contour levels in the middle here on the left. And if I want, I could add specific values by entering them here, or I could click set levels to specify a min, a max, and then a certain distribution of the levels to automatically redefine the contour levels for this group. Just below that, we can make adjustments to the color map that's used for this contour group, or we could select an entirely different color map here. Let's say I want to use a diverging color map, which is useful because these contour levels are centered at 0. And then if I want to, I can import or export any custom color maps that I create while I'm working with my data. There's a lot of other options for adjusting the color map. If you want, we could change from a banded. Here, I'll toggle off the mesh so we can see that a little more clearly. Change from banded to continuous depending on the type of contour we want along the surface. We could add cutoff above or below certain contour level values, or even reverse the color map direction that we're using. So there's a lot of different options that I won't go into too much detail just yet, but there is a lot of flexibility for adjusting your contour. What I will show is the last tab, which is the legend tab, which we can also open up by double clicking the contour legend in the frame. And a lot of different options here as well. So I won't get into detail on that, but what I will show is this quick trick, which is to toggle on resize automatically. And this is a good way to resize the legend, especially if you've added a lot of different contour levels, and it clears up a lot of room in the frame. So next down the list of the zone layers is the shade. I'll toggle off contours so we can see what that is. The shade was what was toggled on by default, and we don't get too much information about our data set from this. We just see the shape of the wing surface, but if I want to, I could right click, make adjustments to the shade if we so choose. In this case, I'll just keep the default. So a couple options for that, but it's not going to give us too much information about the data. So we'll keep it on just as a background, but mesh and contour is what is useful for this case. The last 3 zone layers, we won't be using too much for this demonstration. The vector, we don't have any vector information along the wing surface, so it's not too useful to us just yet. But we will be coming back to this when I show the derived objects and the vector variables they need to be assigned for stream traces. So we'll revisit this for that later. Next on the list is the edge toggle. This just shows the boundary of the zone we're looking at here. So if I toggle this on and off, you can see it bounding at the wing surface. And then the scatter. This just shows the location of the nodes. So it doesn't give us too much for this specific data set because these nodes won't be moving with the wing surface. We're more interested in what the other state or convective variables are doing along the wing surface, and then later on the appearance in the fluid volume. So not useful in this specific demonstration, but for example, if you did have any particle data, for example, if you had a fluidized bed reaction with a code like Barracuda Virtual Reactor from CPFD software, or if you have an internal combustion simulation from a code like Converge from Convergent Science, the scatter layer is a great way to keep track of those particles if you have an animation where you want to track those over time. For now, I'll just toggle off the scatter, so we can get a clean look at the wing surface. So with this, we get a decent overview along the entire wing surface, but if we want more information at specific points, we can use the probe tool. So we can select it from the top toolbar here, or if we have the sidebar already active, we can click this icon. Our cursor changes to a crosshair, and if I probe here, the probe sidebar will update with more detailed information about the variables in our dataset at that specific point. The first tab shows those variable values at that exact point that I probed. The cell center values shows the interpolated values from the nodes that occur in the cell. So for this data set, we have the data saved at the node. And so for the cell center, it's just interpolating from the nodes around here. If we want to, we can control and left click to probe and snap to a specific node. And that way we get the exact information at the node. The other tabs show information about the zone we've probed, and then the nodes, elements, and node numbers for the cell that we've probed. And then the last tab is showing the information about the neighboring cells for face neighbors. All right. And with that, let's show some of the derived objects so we can get information not just about the wing surface, but about the volume that surrounds it. So if I zoom out, we can see this orange bounding box indicating the fluid volume around the wing surface. If I want to toggle that off, I can go to Options, toggle off Show Bounding Boxes, and that clears it up. So the first derived object I want to show is slices. So I click this slice placement tool, which is also available from the top toolbar here. Cursor changes to a crosshair. I left click, and this way we get a slice through the fluid volume intersecting along the wing surface. And with the slice placement tool active, I can press X, Y, or Z on my keyboard to make quick adjustments to change the orientation of the slice. And I can also press A to change it to an arbitrary slice, and this gives us even more control over the orientation of the slice, placement of it, and if I want to, I can adjust where the arbitrary slice tool is located along the slice if we want better control of it. In this case, what I'll do is I'll change back to the X-plane direction, and as it is right now, the slice looks a little washed out just because of the color map we used. So if I want to make adjustments to that, maybe even use a different contour group and contour variable, I can double click the slice. And for now, let's go over to the contour tab. And let's change to a new contour group. And click this icon here to make adjustments to the new contour group that we've set it as. So instead of pressure coefficient or momentum, which has been selected here, let's click on pressure and look at that. And now that we have those both contour groups active, we have two legends. For now, let's toggle off the contour of the wing surface so we're just looking at the slice. And now I get a little bit of a clearer picture of what is happening along the slice. So if I go back to the definition tab, what we're looking at here is a slice plane or a slice through the X-planes. It's a primary slice, so we're just showing one slice at a time, and it's a slice through the volume zone. So if I want to keep this slice active here and then play around with some of the other slice options, I can go to one of the 8 different slice groups that I have available. And let me toggle on Show Slice Group 2, make some adjustments here. And rather than slicing through the volume again, let's slice through the surface zones. So now we've got a 1D slice along the wing surface rather than cutting through the fluid volume. And instead of showing a primary slice, what I could do is show some start and end slices. And for this, I'm going to have to make some adjustments to make sure both are along the wing surface. So let's bring this in a little bit. And what I can also do is toggle on Show Intermediate Slices so that I now have a slice in between the start and end that's equidistant from them. And I can add some additional ones. And this way I get multiple different slices along the wing surface with just one slice group, so that I don't need to be creating additional slice groups for more slices in my plot. So the last button in the Slice Details dialog is the Extract Slices. We'll actually come back to this when I do show the slice extraction. But there's a lot of other useful plot changes you can make to the slices from the Slice Details dialog. The next derived object I want to show is the isosurfaces. Before I toggle this on, I'm going to change the definitions of it so we can get it at exactly the location that we want. So I'll click on the Isosurface Details dialog. And for this, let's say instead of looking at the pressure coefficient or pressure, I actually want to use a third contour group. So I'll change the definition for it there, open up the Contour Details dialog, and let's say we want to look at Mach. And if I want, I could change to a new color map. Let's look at a sequential color map. And we'll leave it as that is there. And then I can change the definition to Mach equals 1. And if I toggle on isosurfaces, we get the isosurface drawn at that Mach equals 1 value. So notice as I do that, we actually get a new contour legend that showed up showing the pressure coefficient. So that's that first contour group. That's because the coloring for the isosurface will use a different contour group than the definition one. So if I want, I could change it to that same contour group that we used for the definition of the isosurface. From here, I can also make some other changes if I want to add translucency to the isosurface, so we can actually see through and see the wing surface. We can also make these kinds of changes from the right-click context menu by right-clicking the isosurface itself. We want to maybe decrease the translucency a little bit, and I can do the same thing with the slice as well. Especially as I obscure some of the wing surface, I can add some translucency so we can see through a little bit better. All right, so the last derived objects that I'll show are the stream traces. I'll toggle off the isosurfaces for now so we can see a little bit more clearly, because what we'll be using is the slice to place some of these stream traces through the volume. First, I'll show what the different stream trace options are. If I click the stream trace details dialog, click here to see the different options available to us. So the first is a surface line. You can actually change the direction that the stream trace is placed in. And then there's a lot of, or at least several different options for seeding the stream traces. If we want to seed them all over the active or selected objects, or if we want to specify exact X, Y, Z positions. For quick and easy placement of the stream traces, I like the stream trace placement tool. So if I click this, I'm presented with this dialog to assign the vector variables. So for this, the vector variables we have are our momentum UVW variables. So I'll reassign those here. And if we ever want to change that, we can click on the vector details dialog here to change these, because the same vectors that would be used on a surface of a zone, if we had a zone that could plot those, will be the same vectors used for our stream traces. And we can also reach that from plot vector to reassign those again. So now if I have my stream trace placement tool, my cursor is a crosshair. If I click, I can place a single stream trace. Let's move on a little further down. If I click and drag, it'll place a rake of stream traces, the default of which is 10 C points for the rake of the stream traces. And I said earlier that we don't have any vector information along the wing surface. That is still true, because what's happening here is we're actually borrowing from the fluid volume to get the vector variables to place the stream traces along the surface line. So this is something that's new for the beta release, and it will be available in the 2020 R1 official release of Tecplot 360, where it's possible to plot surface stream traces for no-slip boundary conditions, as long as there's a neighboring zone with velocity data, which in this case is the fluid volume neighboring the wing surface. So if I want to clean up the stream traces, I could delete them one by one or delete them all together. And let's say I want to look at some of the other stream trace options. Let's change the direction so we can look through not just forward, but backward through the fluid volume. So the first of the volume stream trace options is the volume line. And for this, like the surface line, we need to seed it along a surface. So we can't do that just through the volume unless we have something like a derived object, like the slice here. So if I want, I can click, place the single stream trace of the volume line, which is a one-dimensional line flowing through the fluid volume. And if I rotate, you can see we've got it hovering just a bit over the wing surface, cutting through the fluid volume. The next option down is the volume ribbon. So I can click that here. What the volume ribbon is a 2D stream trace. Last option is the volume rod, which is a 3D stream trace. So if I zoom in a little bit, you can see we've got 3 points defining the volume rod. And if we ever want to change that, we can go to the rod and ribbon tab to change the number of points. And there's a lot of different options for showing the contour along the ribbon and rod surfaces. If we want to use translucency for those, we have a bit of flexibility for that. The other cool thing I can do with stream traces is animate them along this path at this point in time. So if I click this play button, we get these dashes that appear along the volume stream traces that I've placed here. And if I ever want to toggle this off to go back to the regular stream traces, I can do that as well. But the dashes are useful for indicating the flow along those stream traces. So I'm clicking this play button to perform the animation on screen. This film strip icon is what we'll use to export to a file later on once we add a couple more elements to our plot. All right, and that's the last of the derived objects that I'll demonstrate for today. Just below that, the last two toggles on the plot sidebar are for the effects. We can toggle on and off lighting. We can change the light source. Notice that the lighting is affecting the wing surface as well as the stream traces, whereas the toggle down from it, translucency, is only affecting the zone. So if I want to, I can right-click the zone to adjust the translucency. I could even toggle it off altogether if I want certain zones that are translucent and certain that aren't. But if I want to make changes to the derived objects, I got to do those independently. So the translucency toggle is for the zones. And we'll keep that off for now. Let's reduce the translucency in the slice just a little bit. All right, so that's a quick tour of the plot sidebar and exploring your data set. Next, I'll show how to calculate some new quantities from your existing data. So the first option for that is to use the Data, Alter, Specify Equations dialog. And what this allows us to do is define new variables or even modify existing ones in our data set based on the equation we enter into here. So I can open up the Dataset Info tab to reference the zones and variables that I might want to modify. I can alter zone by zone or all at a time. I can change the variable data type that we're outputting. I can change the location of the variable that we're using inside the data set here in Tecplot 360. And rather than typing out the equation right now, I've actually got it saved. So I can click on Load Equations and select this EQN file so that I can quickly get that filled in, especially if I'm reusing the same type of equation over and over again. So for this, I want to calculate the momentum magnitude from our UVW momentum variables. So for this, I'm actually using a shorthand. I could type out the entire variable name if I wanted to, but in this case, I'll just reference our fifth variable, or V5, which is our momentum U, and then V6, V7 for V and W. So that's a nice trick for quickly referencing, especially very wordy variable names. So in this case, I'll click Compute. It says data alteration successful, and we'll actually have a new variable added to our dataset info list. So of course, nothing along the wing surface for the momentum, but if we go to the fluid volume, we can see the range for that. And if I want to plot that, I can change the slice from the pressure. If I double click the slice, go to the contour, select the contour group that it's referencing, and let's change that to the momentum magnitude, and that way we can quickly plot that. Maybe I want to drop this a little bit further so we can see it a little more clearly. So that's one way to calculate a new variable. The other way is to use the CFD Analyze tool set. So if I click the Analyze drop-down menu and select Calculate Variables, we've got this Calculate dialog, and what this is a list of predefined equations for commonly needed variables for analysis in your data set. For example, let's say I want to calculate velocity magnitude this time. So I select that. If I click Calculate, I'm presented with this error message indicating that I need to provide more information to the CFD Analyzer, which is this drop-down here. So for that, I'm going to go to Analyze, Field Variables, and define the variables that I need here. So the momentum has already been selected, which is great, but our state variables need to be picked. So if I click here, I know that we have pressure and temperature in this data set. So I'll select those from our list of variables. I click OK. Now if I click Calculate, we have this message indicating that Calculate on Demand was successfully set up, and that's what this toggle right here does. So what that means is the equation is set up, but the variable isn't actually loaded until some specific plot element demands it. So if I look at the dataset info dialog, just for reference, we have this new velocity magnitude, but it says variable status not loaded, and that's because we don't have any plot elements referencing it. So what I could do is the same thing we did with the momentum magnitude, change this contour group from using momentum magnitude to velocity magnitude, plot updates with the variable we want, and then we see that the variable is loaded in our data set. All right, and those are the two ways you can calculate new variables within Tecplot 360. So now I'll show how to do some data extraction. So if we go back to the Slice Details dialog, that definition tab for slices, we have this Extract Slices button in the bottom. If we want to see the other extraction options available to us, we can go to Data, Extract, and see from the full list of which derived objects we can extract and other plot elements if we wanted to do that. So for now, what I'll do is make sure I select the right slice group, click Extract Slices, and I'll keep the defaults for now. And if I hit Extract, slice extraction successful. And if I go to the Zone Style dialog, we'll actually see a whole new list of zones that are those slices indicating the position along the wing surface, the slice is and where it was extracted from. So from here, if I wanted to, I could write out those slice zones by going to File, Write Data, write those out to a new data file. In this case, I could keep it in the same instance of Tecplot 360 we have here and do some additional plotting with just those slice zones. So a way to create a new plot on the same workspace is to draw a new frame, and that way we don't interrupt the existing work we've done with the 3D plot here. So to draw a new frame, I can go to Frame, Create New Frame, or I can click the same icon from the top insert toolbar here. My cursor changes to a crosshair, I click and drag. Now it's as if we're starting over. We get a blank plot sidebar because we don't have the data in just yet, but if I change the plot type to XY line, what this does is it instructs this frame to inherit the data set underneath it, which would be the 3D volume, wing surface, and the slice zones that are in this frame. So a quick shortcut for this, I'm going to select this bottom toggle so that we create these XY line mappings for each linear zone, which in this case would be all of our slices that we just extracted. We'll keep the X-axis, and let's change the Y-axis to look at the pressure along the wing surface. If I click OK, then we instantly make these XY line mappings for those slice zones. So I might want to make some quick adjustments to the plot itself. So if I use this adjuster tool, I can slide the axis label out a little bit. I can move the actual axes out. And if I double click the axis, I can go to the range tab and change the axis direction. So we get a plot that's a little more familiar looking. If I double click the lines, this will open up the mapping style dialog for that specific mapping. So the mapping style dialog looks similar to the zone style dialog, but it isn't quite the same. We're just looking at the XY line mappings we've created, and we can create additional ones from here. It'll show which zone is being referenced, which variables are being used for the plot, and then if we want to change the map name, we can do that as well. In this case, it's useful because it indicates where on the wing surface it was extracted from. If I go to the Lines tab, I can make adjustments to individual mappings. So let's say we don't like this gray, so we could change it to a little more vibrant color. In this case, now we've got two sort of red-looking line mappings. So if we want to change the line pattern for one, we could change this to dashed so it's more obvious where the distinction is. I can Control A to select all the mappings and change the line thickness to make them a little more clear. And to add some additional clarity, we can go to Plot, Line Legend, and toggle on Show Line Legend. So now that on the plot itself, we can see which line mapping is referencing which slice along the wing surface. So right now the frame is, this frame is overlaying the 3D plot view. If we want to, we could double click the frame and toggle off Show Background so that we can see through it while still seeing the line mappings with the rest of the plot. So now, if we're happy with the way our plot looks for now, or we want to be able to share it with our colleagues, we'll need to be able to export that. So in order to do that, what we'll do is we'll go to File, Export, and this brings up the export dialog showing the different raster and vector image export formats that you can output into. Change the region, so we've defaulted to all frames for this case. If we want to just export frame by frame, or the entire work area, which is this gray background the frames are laid upon. In this case, all frames is perfectly suitable for what we want. We can redefine the width if we want, toggle on anti-aliasing depending on the quality of the plot we want to export, or how quickly we want to be able to export it. If I select OK, I can just say Export 1. And that way we'll have an image we can share with our colleagues if they haven't started using Tecplot yet, or if we want to use our plot in a presentation. So that's export option number 1. The other export option is to export an animation. So I'll go back to the Stream Trace Details dialog for that. And if I click this film strip icon, it shows the different export formats to video files, or if we want to export into a sequence of images, we can do that as well. Similar options for anti-aliasing, redefining the width or the region. That way you can get exactly the type of video animation that you want. So every derived object that has animation will have this film strip icon in the Animate dialog for it. So we could hunt through each of the dialogs for those and go to the Animate tab to be able to animate these, or we can go to the Animate drop-down menu to see the list of all the different animation options available to us rather than having to click back and forth between these. One animation option that is specific to the 3D plot view is the keyframe animation. So if I toggle on this, what we can do is we can append specific 3D views. So let me just add a couple of these. And then if I hit animate all, what this does is Tecplot then stitches together those different views to create a seamless 3D animation view of our plot. So this is more for making slick looking presentations if you want to show off your work. The other thing we can do with this is animate with a time animation if we add a transient data set. Unfortunately, in this case, we don't. But we can also animate concurrently with stream traces, which we do have. So if we toggle that on, we can select animate all. And then with our 3D plot view, let me just move this down a little bit. Not only do we get this rotation throughout the 3D view, we can see the stream traces animating along that, adding a little extra excitement to our animation if we want. Unlike the other video animation exports, we can change to destination to file in order to export it as a video file with a couple different options for that. All right, and that concludes the basics I wanted to cover for learning Tecplot 360. So for now, I will switch over to some of the questions that have come up to answer those. Just a reminder, if you do have questions following this, or if you have any questions while using Tecplot 360, I highly recommend contacting our support team at support@tecplot.com or support-eu@tecplot.com if you're in Europe. Links to specific tutorial videos at tecplot.com/videos that are 3 to 5 minutes long and targeting specific topics. Those can be really useful as well. And if you go to tecplot.com/CERT to get certified as a official or a pro Tecplot user, that's a great way to get you started learning even more of the basics of Tecplot 360. All right, and with that, let me bring up some of the questions that have come up to see what we can answer.
And Jared, I'll chime in here. This is Scott Fowler, Product Manager of Tecplot 360. A lot of good questions coming in. So Jared, while you're catching up on the questions that have been asked, why don't I'll just verbally answer a couple that have already been asked. So are you guys going to cover PyTecplot today? Clearly, Jared did not cover PyTecplot, but we do have a number of videos on our website that can help educate you on the Python scripting. If you go to the main Tecplot page and click on the support tab and then videos, there will be a set of categories and you can search for PyTecplot there. And if you still need help with PyTecplot, you know, the learning curve can be a little bit steep. Do contact support@tecplot.com, like Jared said at the beginning of the video. Will you get a recording of the webinar? Yeah, we're recording this, and you'll get a recording via email in not too long after the webinar. Let's see, is there a way to find the minimum and maximum value of a variable? Jared actually wrote a really nice Python script to do this. This isn't built into the user interface directly, but Jared wrote a Python script about that and posted it on a GitHub page that we maintain. A link to that should be available to all of you in the questions panel. Jared, do you see any other questions in here that you want to tackle?
Someone saying, which export format do you recommend? I guess the export format I would recommend is our Tecplot binary format. If you're using, I'm assuming you're using your own simulation code for that. And from our website, we have the libraries for our TechIO input-output library if you want to export into Tecplot format from your own simulation code. And that's going to be the best way to bring your data into Tecplot 360.
Okay, and this question I think may have come up while you were exporting images and videos.
Oh, okay.
So how about, do you have any recommendations, Jared, for export formats for videos and images?
Yeah, so for the image export formats, we have the JPEG, PNG, BMP raster image exports, and then the EPS and PostScript vector image exports. So the vector, of course, are going to scale a bit better, and you're going to have slightly more detailed plots for the quick image exports, and for I guess more easily shareable image exports, I recommend the raster, the JPEGs, the PNGs, stuff like that.
Yeah, so I guess to summarize, so PNG I find PNG to be quite compact export and really good for the 3D plotting, the 2D plotting. The vector formats are great if you're putting results in a paper or need to print it. And then for movies, MP4 seems to be the most portable. So I'd look at those formats.
Mm-hmm.
We had a user ask about CFD++. Is there a direct import option of CFD++ data available in Tecplot? Well, CFD++ does export to Tecplot binary format directly. So if you are able to export to the PLT format from CFD++, I'd recommend that. As Jared showed at the beginning of the video, we do have a number of other formats available, CGNS, etc. So if CFD++ does export some of those, I'd take a look at those formats. Can you read Autodesk CFD files? That's a good question. We do have a lot of loaders. I'm not sure. We don't deal with a lot of Autodesk type files. We can read STL. So if you're bringing in just a geometry, we can read the STL format. But if you do have a data file that you want us to try to load, please contact our support staff, and we'll see if we can update Tecplot or find a alternative for you to get it in.
Looks like one of the questions here said, if I switch to a predefined view in 3D, let's say an XY view, can I control the direction of the view? I think that's referring to the snapped orientation views. So for that, yes. Once I do the snapped orientation view, I can manipulate the plot as normal. These are just sort of quick shortcuts to get the view to these specific views if you want a quick reset. So you can manipulate those following the change pretty easily.
There's another one. Can you integrate the pressure along the wing surface to get the net force? Yes, we can. That's available under the Analyze menu and Perform Integration. And you can do integrations. We can also calculate forces and moments. I included a couple of links in the question panel, but it looks like one of the links was broken. But those are easily searched on our website. And if you do need help, additional help in finding those links, we can guide you. Again, support@tecplot.com is a great way to get help as long as you're a current Tech Plus subscriber. A map view of a terrain where Z changes with X and Y. Can I tell Tecplot to show an XY view only the topmost layer of nodes? Because sometimes it shows contours from underlying layers. Yeah, so this is an interesting question. So in geosciences, like we can open FBCom data, and if you're showing a 2D plot, so if Jared were to go to the plot sidebar and select the 2D Cartesian menu, if you're in 2D, Tecplot has no concept of depth in that view. So because you do have data in the Z dimension, OpenGL, which is ultimately rendering this, doesn't know whether to show the top nodes or the bottom nodes because we have no Z axis assigned. So if you do want to see a top-down view and you have a change in Z, it would be best to view it in a 3D plot and top-down. So I hope that answers your question. If it doesn't, we can again follow up via email or phone call.
Looks like one of these questions says, can we do derivation of the variables in the equation editor? Yes, so or at least from the specify equations tool. So if I open this up, this is actually a useful link for all the dialogues. It brings you to the page in the user's manual specific to this dialog. And for the specify equations dialog, we have the section on the equation syntax. And we also have a list of the different expressions and operators we can use. And then down by the bottom, it shows how to do different derivative and differencing functions if we want to do a derivative of an existing variable. So yeah, if you ever want more details about the dialog you're looking at, this help button in the bottom right is great to point you in the right direction for that.
Okay, another question here about exporting images and video formats. It says that it seems that all the formats seem to lose some quality comparing to what you see directly from Tecplot. One thing that you can try is using the anti-aliasing, which Jared has the mouse over. Anti-aliasing is going to smooth out the lines in the text. So the way Tecplot works is we actually go through different rendering code when exporting to an image as we do on screen. Everything on screen goes straight through OpenGL, and then everything going off screen has to go through a different branch. So there can be slight differences in the output and the output quality. So I recommend doing a larger image. So you can say enter width on there, and using anti-aliasing with an aliasing value of 2 or 3. You might even bump it up to 4. We do allow up to 16, but anything above 3 or 4 doesn't really make a significant difference. So try that anti-aliasing toggle and see if that helps you out. I see. So okay. Snap views. There's a question about the snap views, Jared. It sounds like you were about to answer that. So why don't you go ahead?
Yeah. So it sounds like we snap to the specific view. You want to change the at least the zoom level, or not, so keep the XY consistent. Change the negative positive Z perspective, not rotating again. So if we did XY in this case, so we keep that the same. What we can do is we could zoom in and out without having to translate in the X or Y direction. So we don't have to do a full plot rotation or plot manipulation to really snap to that view. Hopefully that's what you're asking.
Jared, I think this may also refer to the direction of the Z-axis. So right now, I don't recall in this view if Z is pointing out of the screen or into the screen. So this would be, let's say Z is, can you rotate the plot around, say the Y-axis just a little bit, the X-axis. So it looks like in this Z is up, so pointing at us. So you may want to go Z negative, Z pointing down. We don't have a quick a button to quickly snap to that, so you would have to rotate the plot 180 degrees. That can be done precisely in the 3D rotate dialog, but that is a suggestion we've heard before, so we'll take that under advisement that we should have effectively a whole nother set of those toggles for positive Z, negative Z, etc. Okay, well, it doesn't look like any more questions are coming in, Jared.
What I'll close with is I'll toggle back on this welcome screen. So if you do have questions following this, another reminder, please contact us at support@tecplot.com if you do have any questions about the webinar we've just done, or if you just have any specific questions that come up while you're using Tecplot 360 in your own work. You can email us, give us a call. You can even send a support request through our website, and that way we'll be able to help you with your work faster and help you get your work done faster as well in Tecplot. So with that, thank you for attending today. Hopefully this is helpful for getting you started using Tecplot for your own work. Yeah, thank you very much and have a great day.